Well, good afternoon to all the viewers and my dear students. Last time we were discussing the various concepts related with the, if you can able to recollect. So, last time I was discussing on what is called as the resolving powers of the optical instruments, where I told you the resolving power of the optical instruments, it depends upon a lot of things. Even if you can remember, we said the resolving power of a microscope. Now, once again, maybe there is a gap, so I will just narrate the various concepts, phenomena related with the resolving power. Resolving power, it means the ability of instrument to show two closely lying objects, if it is far or near, separately. Now, this is what we said, that if you can see a point object which are lying at a far away place, if you can allow these the light from the point object, now you can see a black spots are seen, that is the diffraction patterns can be seen. So, this is nothing but the diffractions. Now, now here if you can remember the resolving power, it is an ability of the instrument to show two closely lying objects very clearly. Even I told you the last time also, if you can remember the concept, a well known concept in science, no two objects will occupy a same space at same time. If that is the concept. Now, to understand the resolving power, now whether there are really two objects are there, if it is single objects, if what is the separation between them. So, there now we that is Rayleigh has given his criterion. So, that is if two objects are separated by certain distance, now to a naked eye you can see these, though it is a two object, you can see with your naked eye they are looks almost a single object. Now, suppose the objects are, suppose we want to resolve in the sense we want to see it. Suppose we want to see it, we have to conduct a very simple experiment. So, that is, let us imagine, so this is the objects, let us say if the two objects, take black, इसको एक बार चार्ज पर लगा, नहीं
चार्ज पे चल नहीं रहा,
नहीं अच्छा
नीचे यूज करने
नहीं, पूरा ब्लैक नहीं आ रहा क्या? बोर्ड ले लो,
बोल लेना।
Now, if you can recollect here, see there are, I have written, there is a spot. So, the spot may represents that there may be two objects may be lying. Suppose the light from these two objects, if it is falls on a, say for example, a slit. Now, here let us imagine this slit is nothing but our eye, and there is a retina of our eye here, this is the retina. So, whatever the light getted diffracted from this object, we can able to see it. Now, as per the Rayleigh's criteria, that is if these two objects, if it is forms a prominent peak like this, so that means the maxima of the first object, if it is almost in coincide with the maximum of the other object, if this distance is very small, then if though the objects are close by, we cannot able to resolve it. So there is no question that we can able to see it. Now again, if these two objects are there, they are very close, again if it is falls on our eye, then what happen is, suppose this is the retina, then we can able to see the curve. So that means if this curve, this is the curve of the first object, and this is the curve of the object 1, and this is object 2, this is the maxima of the first object and this is the minima of the second object. If the principal line, if we can allow this to pass through this, then if this distance is large, then we can able to see these two objects are very clearly, it is can be seen. Suppose here again, if the two objects are little separated by distance, then we can have a what is called as a retina, then we have a dip here. If this dip it is prominent, then we can able to see these two objects very clearly, that means this can be resolved. So this is the some of the criteria was given by the Rayleigh. Based on this criteria, the instruments can be designed, and this is the certain energy levels. Last time I told you, even see we said about how best one can able to resolve the power of a microscope. Now here is the resolving power of the microscope, that is d theta. Here you can see it is d, it is, you can read it as d theta is equal to lambda divided by 2n into sin theta. Now here n is the refractive index, so and lambda is the wavelength, and theta is a semi vertical angle which is being formed between the object and the site. So here is, suppose we want to increase the resolving power of a microscope, that is either you can increase the refractive index. If the refractive index, that is the media lying between the object and the eyepiece, if this is been increased, then definitely the resolving power of the microscope is increased. Now how it is been increases, now certain oils are used whose refractive index almost same as that of the glass, so that will increase the resolving power, or by increasing the theta. By increasing the theta, that is by size of the objective lens, if it has been increased, then again the resolving power of a microscope will increase, or else by decreasing the wavelength. So that is rather allowing the visual light, that is the daylight. So if we can allow the ultraviolet ray or the infrared to get reflected, so then the resolving power of the microscope can be increased. So this is how the resolving power of the microscope can be increased. Now some of the problem last time we solved, remember this. Now let us come to the resolving power of a telescope. So if you can recollect, I told you about this telescope also. So here tele means far away, scope is an instrument. So that is, the telescope is an instrument used to see the far away object, that is the distant object. Suppose if two objects are lying far away, suppose we want to see them as clearly, then we use a telescope, or you might have been familiar with what is called as a binocular. The binocular is been also been used. So here what is the real concept? The concept which has been used in a telescope is, so that is, when let us imagine that again there is a You can imagine this is a slit and the light is falling. This is the light is coming from a far away object. Light is coming from say infinity. If it falls on this, as you know that, so the light will undergo diffraction. Now suppose if we can place a lens here, so this is the lens, and if you can place here, this all the rays which are been coming from a far away object, and these rays are getting scattering from the object. Then if you can able to collect these rays by using a lens with a larger aperture, then there is a possibility that we can able to see the object. Now on other side, suppose if you can see, if you place your eye this side, if we can place the eye this side, then we can able to see this. Now here is, once the light as it passes through this, so let us imagine, so this is an angle theta. So that is, so this angle theta has been very important. So here this is called as the angular separation between the two objects. Suppose if we can study these angular separations, then we can able to distinguish the two objects which are lying far away places. Now now this theta, the angular separation depends upon what are the factors. So I will show you in some slides. So that is, see here the angular separation, that is d theta, it is given by a very interesting formula, that is 1.22 lambda divided by d. Now here this 1.22 lambda, 1.22 is a constant and lambda is the wavelength of the light, and d. Now here is d, it is referred to the diameter of the objective of the telescope. So that is the objective in the sense the lens which are pointing towards the object. If the diameter, or sometime this diameter d, it is also called as an aperture. So this all d is also called as aperture, and this formula we can also write it as a. So d is, you can also replace by a. So here a is also an aperture which is nothing but the diameter. Now a simple formula here is, suppose this angle which I told you, the angle of separation between this angulars, this, so this depends upon the wavelength of the light. Let us keep 1.22 is constant. So it depends upon the wavelength of the light. So that is, if the wavelength of the light is more, so that is the angular separation also increases. So that means if you are using a visible light whose wavelength is more compared to the invisible light, then what happen is, so the angular separation will increase. Again depends upon the d. Since the d is in a denominator, if the value of the d increases and the value of d theta decreases, so that is, if the size of the aperture is more and more, bigger and bigger, then the angular separation theta became small. So now the resolving power of a telescope, it is given by this formula, that is, it is the reciprocal of 1 divided by d theta. So that is, the resolving power of a telescope is equal to, it is equal to d divided by 1.22 this. So here, since the light lambda is constant, so that is the resolving power of a telescope only depends upon the diameter, or it only depends upon the aperture. So that is, wider is the size of the objective of the telescope. That means such a telescope can able to resolve two lying object closely very clearly. So the hence, in order to see a far away object, so it is preferably, so we will use a telescope with a larger aperture. As the size of the aperture is more and more, so that means the resolving power is also increases. So, another concept I can give you here is, now when you see during the night times, that is when you see the headlights of a car, the headlights of the car are at a fixed distance. These dots represents the headlights of the car, and which is at a fixed distance. Now, suppose there is a obstacle, and this obstacle is nothing but the eye. Now, you can keep your eye here. This is your eye. You can keep your eye here. Now, what happen is, so there is a fraction will takes place. So, here this is, let us say this is the distance, and here you have an angular separation between the two objects is theta. As the car approaches, this angular distance theta goes on increases. So, again as the car is quite near, that means this theta goes on increases. What does that means? It means earlier when the two lights of a car which is at a far away place, when it is falling towards our eye, now our eye cannot able to resolve whether it is the light coming out from a car or is the light coming out from a single vehicle. Suppose if this is been not properly judged, so majority of the accidents will takes place during the night time. Now, as the car approaches, comes near and near, so that the angular separation theta goes on increases. As it goes on increases, then only we can able to analyze whether it is a really car or what. So, so this is how the resolving power of a instrument. So, it depends upon this angular separation, and it also depends upon the aperture. Whereas, suppose we have certain what you call it, the radio telescope we have, and this radio telescopes now which has been used to see the distinct stars, now whose aperture size is in terms of meters. So, maybe it is around 30 meters, 50 meters and so on. As a result, as the apertures are increased, so that is the instrument can able to resolve certain those objects very clearly. I hope so that is you have understood what actually meant by the resolving power of the instrument. Now, let us move on to one more concept that we called as polarization. So, that is, as you know, that this is a very interesting phenomena, and now as you know that light is a form of energy, it propagates. That is, earlier we said about there are a lot of theories were put forth, and Maxwell said that, so this light, it is electromagnetic in nature. Earlier people thought that the light is longitudinal like sound waves, and never knows that is a transfer in nature. The light is transfer in nature, it is established only by phenomena of these polarizations. So, polarization has given an evidence that light is purely transfer in nature, it is not longitudinal in nature. So, light is transfer in nature, and certain experiments have been conducted to prove that the light is transfer in nature. Now, here is, let us try to understand what actually this polarization is. Now, why we say the light is transfer in nature and so on. So, the concept here is, let us try to understand the electromagnetic nature of light. So, that is, Let us try to understand the phenomena of polarization. And in fact, so this is a very difficult process to understand this. Anyway, I will try to convince you in a very simple way so that you can able to understand. Now let us try to understand how does a wheel obtain the light. Suppose if you can imagine, there are various sources of lights. One of the source, let me take up, is a incandescent bulb. So a bulb has got a filament, and the filament gives light. The light is coming out from a bulb. Now here is again, how does the light is being obtained from the bulb? Now actually what happened, so there are electrons inside, and these electrons will be accelerated to a high potential, and that will use light. So that means as the electrons get accelerated in a potential barrier, so it emits energy. That energy we call it as light. Now, and light is electromagnetic in nature. So that is, it is having the property of electric and as well as magnetism. Now the question is, how does these two properties will form on a single light? So that is, let us imagine this. So this is an x axis and a y axis and a z axis. Suppose if the wave nature of light, this is the electrical property. So that is, this is the electrical property, say E. So it will try to travel along x axis and a y axis. Now this is, now in fact, it is also having a magnetic property, and the magnetic property of the light, it will be along this direction. So that is, say B. So these two are mutually perpendicular to each other. So that is, the magnetic property in a light, it will try to guide as a result. So this is the propagation. So this is the case of a single electron which emits lights. Now from the source there are millions and millions of electrons are emitting light, and each electrons are electromagnetic in nature. If that is the case, then if you can see the light, it looks like this. It looks like this. So here let us imagine if these two are taken as the two mutually perpendicular field, this is an a electrical field, and say this is the magnetic field. Then if you consider these two, again this is an electrical field, again is a magnetic field. If you consider these two, then again either it could be an electric field or it could be a magnetic field. So as a result, you will see that, so when you see a distant source of light, so when you see a distant object, it as it appears like a shiny, it shines in all the directions. So it shines like this, as there in the figure. So this is how the light is being represented. Now we wanted to remove all this. Now we wanted the light to allow in a particular direction. Now here, so say for example, let us imagine that if I write a line like this with an arrow both the side, so this represents that the particle will vibrate along with this in vertical direction. Suppose if I write a line like this, this represent the particles are vibrating in a horizontal direction. If you can put together the two on this, so this represent the combined effect. There are particles are moving along the vertical plane and there are particles which are moving along the horizontal plane, and so on and so forth. Now suppose we wanted to allow the vibration of a particle in a particular plane, then what do we get? So that is, let us imagine we have a source of light. This is a source of light. Then imagine this is an imaginary axis. This source of light I will represent like this. Then in front of this, so what I do now, suppose if I can use a vertical slit, I will use an object which is having only a vertical slit, and this slit, vertical slit, what does it does is, whatever the light which vibrates in all the direction, now this slit will allow the vibrations to pass in only in a particular direction. So that is whatever the light I am getting it. So that means, so this slit, it allows the vibration of the particles only in the direction of the slit. So here, if you can look this light from this side, if you can keep your eye this side, if you can see this object directly, then this object, it looks, it is shining in all the directions, it is burning at a very high, say at a high intensity. If the same object, if you can see through that, so you can able to see it. Now how you can able to see this object? Now yes, you can see the object. Here is the majority of the vibration has been removed, and the vibrations which are parallel to this slit is been allowed. So that means you can see the same object from the side, that means whose intensity will be reduced. Now, so this light now which is passing over this type of arrangement, this light we called as a polarized light. So this is a polarized light. And this is a unpolarized light. Now next what we can do is let us try to check whether this light, it is really polarized or not. So what is the check you can do it? Now you place one more similar slit in this way. So again you place one more a similar slit in this way. Then if you can see the same light other side, then this will shows that the light is vertically polarized. If the same slit, if you can turn into 90 degree, the same slit you can just turn into say 90 degree, say like this, then you can't able to see this. When you can't able to see, that means the total light intensity is been reduced. So that means it only shows that this light is polarized. Now here this slit which makes the light to polarize, so this is called as a polarizer. To confirm whether the light is polarized or not, and you are putting one more, this is called as a polarizer. And the polarizer also we can also call this as an analyzer. So which has finally analyzed that the light is coming away is a polarized light. So I can show you certain interesting phenomena with this light is. So, that is, otherwise it is rather difficult to understand. Now, I have a certain paper cuttings. You can see this paper cutting, this resembles a sine wave. This is a sine wave. I think all of you can see in this is sine wave. Now, we have, imagine this is a crystal, this is a, if you can hold like this, it is a vertical slit, and if you hold like this becomes a horizontal slit. Now, let us imagine that light is now coming and falling through this. So, that is, light is transfer in nature. So, let us imagine this is the sine wave. At this sine wave, as it enters through this slit, and the slit length is so wide open, whatever the vibrations which are taking place, and these vibrations are fall inside, and this can able to move. So, the sine wave, the entire sine wave will pass through. So, there is no doubt in it. So, that means, so the light which is having all the vibrations in all the directions, it is having a mixtures of vibrations in all the directions. Now, if you allow this, based on the direction of this slit, I have hold vertical, it will allow only those vibrations, vertical vibrations only it will allow. It will not allow these horizontal vibrations. So, that means, so this slit, it act as a polarizer. So, it has polarized the light. Now, whether to check whether the light which is been coming out from this polarizer, it is really polarized or not. So, what we can do is, we will place one more slit in the opposite direction. So, as a result, the second slit will tell us whether the light is polarized or not. Now, what we can do is, let us hold the two slits like this. So, these are the two slits. Come, hold this. So, you can imagine this. Let us imagine this is the sine wave now. Now, the sine wave we are allowed into this slit, उसको थोड़ा आगे लेगा, and this is also in a same parallel direction. So, you can see that, so this will be able to pass through. Now, suppose you make this is one of the slit perpendicular to this plane, then what happens, this slit will able to allow the vibration, but this is, it will not allow. So, this slit will allow only the horizontal vibration. Now, this is not there. That means, the light is passing through this slit, whereas the light is not passing. So, this slit will obstruct the light. If you can see this phenomena from this side, if you can see this phenomena from this side, you can see that it is totally dark. If this is in a same direction that of this, that means this. So, this is the simple concept now which has been used under the polarization. I will give a demonstrations with, we have certain polarizers. So, these are the polarizers. I will explain you later on how these polarizers will work. Now, I am having two polarizers. If this polarizers, if I can place it on You have to focus this here. You should turn gale. Can you come this way? I'll focus on the board only. Huh? Just observe here. Can you see the board? I will write here something. See, I will write certain, say for example, I will write the letter P. Now this P, now I think you can see it. Now if I cover this P with this polarizer, then only this letter is partially seen, right? Suppose if I turn this to certain angle, you can see it, but it is not that clear. Suppose if I can put two polarizers, one in this side, other is this side. Now you can see this, it is totally dark. You can't able to see anything. Suppose slowly if I can remove, see this appears, you can see that. Suppose if I can put one more, it is totally dark. So that means, so these are the polarizations. I think best effect these polarizations I can show you. I have slides. You just escape this.
Video.
Oh. It is a very interesting effect, you can see that. Go, 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 lost. Yeah. See, this is one. Actually, this is the one which I have shown. It's a sound mute purpose. And see. Okay, let it be. No, go for this directly. Now just observe this. See, if you go and turn these crystals or the glasses to 90 degree, see the effect. See, the total effects are different. If you can turn it, see the effects. See, totally it becomes dark. That is what I have shown you. When dark means it will not allow the light to pass through. Can you see, show this sticker? Yeah. So now I can show you one more. I say, you see that. So there is a sticker, and with the naked eye you can't read anything which is been written on a sticker. Now suppose if you can see this sticker with this polar, you can able to see. Just see that some letters are visible there. So there are certain pictures now which is totally hidden. Now we can't able to see with the light. So I mean with the ordinary glasses, especially if the glass is really polarized. This is one of the tests you can do it, because in market lot of goggles are available, and they say that this is Polaroid and that is Polaroid. To check the polarization effect, thank you. To check the polarization effect, so this is the one of the test. So you can able to do it. Right. This is a very interesting test. By means of this, one can able to understand whether there is a really polarizations are taking place or not. Now let's come back to the phenomena of polarizations. So as I told you, so polarization is a very interesting phenomena. So where it is actually it is a very complex process. So one, it is very difficult to understand. Now with the sketches, so I have explained you what actually meant by a polarization is. So that is, as the light is electromagnetic in nature, now the plane of vibrations will be in all the directions. So now we wanted to polarize the light, so we require a certain crystals. Now what is the idea how that crystal can able to polarize the light? Now there is a crystal called as calcite crystals. So where the molecules of that crystals is almost the size of the molecules of the crystal is almost equal to the size of the wavelength of the light. So then what happened while play this? Well, the geometrical pattern of these molecules, which are been present in a crystal, like even a crystal like tourmaline. So the wavelength of the tourmaline molecules almost same as that of the visible light, wavelength of the visible light. When the visible light is allowed to pass through, then these molecules, it will allow only a particular light which has been vibrating in a particular direction. So it will not allow this. So this is a very interesting arrangement, which we can see in case of tourmaline crystals. So so the tourmaline crystals can able to allow the light to pass through in only in a particular directions. Now this is what we have explained earlier also. So where the intensity of the light is totally been reduced. So the intensity which is being reduced, and we call this is as a polarized light. This is a polarized light, and this is, so these are the crystals, and this is called as a polarizer. And here we are demonstrated with a simple experiment that if you can able to turn this to a 90 degree, it will not allow. That means you are seen while giving a demo through the polarized glasses. When two polarized glasses whose axes are perpendicular each other, then it will not allow this light to pass through. So totally it will block the light. If the axis of both the crystals are parallel to each other, then it will allow the light to pass through. The light coming out from this crystal, it vibrates in only in a particular direction. That is, direction depends upon the axis of the crystals. So here as shown in the figure is, so the crystal axis is vertical, so it will act as a imaginary vertical axis, and it will allow only in a particular directions. Now this is how the polarization will takes place. Now these are the some of the figures, that is, so the unpolarized light, either it can be written jump in this can be shown like this. Now here the light, or the light can be shown like this. If the light can be shown here, this is the vertical plane, and the dot represents that the vibrations are taking place in a horizontal directions. So that means, so by showing this, so there are here only two planes are shown, that is, one is the vertical plane and another is a horizontal plane, whereas this shows the vibration of the light will almost in all the directions. Now this is a, we can call it as a ordinary light, and this is where we are considering only the vibrations in two directions. So it is also a ordinary light, it is not a polarized, but it is referred as an unpolarized light, right. Now here is again, this is a ordinary light. Suppose if this is been shown like this, that is, the vibrations are allowed to pass in only in vertical direction. So this is almost a partially polarized light. Suppose if it is been shown like this on a same line with certain dots, so I said the vibrations which are taking place in a horizontal direction, so this has been shown like this. So that means this represents, that is, so the polarizer, it is allowing only the horizontal vibration to pass through. So that kind of polarization, if it takes place, so this is shown like this. Now the methods, what are the interesting and very important methods for the production of the polarized light? So basically the most important methods are one, we have a polarizations we can obtain due to reflection of light, and polarization we can obtain due to refraction of light, and third parameter is a double reflection. Now here is, I think it is very clear what is meant by reflection of light. So that is, whenever the light falls on certain opaque substance, the substance can able to reflect the light in a same media, then the process is called as reflection. Now, whereas in case of refraction, so especially this will take place when the light passes from one media to the another media, and provided the other media should be a transparent media, then what happen, the refraction will take place. So by these two methods one can able to get the polarized light. Now let us see the polarization by reflection. This is one of the simplest method to obtain the polarized light by what is called as reflection, and this was been discovered in the year 1808 by Malus. So he said that whenever the light falls on a certain substance, it will get reflected. So when the light strikes the opaque substance, the sum of the energy of the light, it has been totally absorbed by this media. So there what happened is, the intensity of the light it is being reduced. as the intensity of the light is being reduced, so that means the light after reflecting, it is nothing but a polarized light. So this is what so Marius said long ago. So that means whenever or wherever the light will undergo reflection, the reflected light, it is almost a polarized light. But the degree of polarization, whether degree of polarization, that is whether that kind of phenomena can be used to get a polarized highly polarized light. To obtain the highly polarized light, so again certain experiment has to be conducted based on the reflection only. Now by means of which we can able to get. So that is a simple experiment is let us imagine we have a media which consisting of air and a glass. Air is at a rarer media and the glass is at a denser media. Whenever the ray of light falls on this at the point, so this is the light which contains the vibration in almost all the directions. As the light hits the surface at certain angle, it will get reflected, and since the media is a transparent media, then the same light also undergoes what is called as refraction. So that is, refraction is the bending of the light away from its normal direction. So here is so the light which is falling at this point, now which is totally a unpolarized light, when it hits and get reflected here, so this is a polarized light, and the light again, the same light only, it is entering into the media. Now since it is the same light entering the media, so that means this light is almost a unpolarized light. But what we can notice is the intensity of the light. Now before this striking, here the intensity of the light will be more. As it undergoes, then some of the intensity, that means the some of the plane of vibration is being lost. So this is how, so here this is being represented, but so as the refracted light will consisting of two planes, so that is, one is a vertical plane, another is a horizontal plane. But anyway, so this is nothing but a unpolarized light. It is not a purely a polarized light. Whereas the reflected light, this reflected light is polarized light. Now here is, suppose if you can able to control this angle of incidence, if you go on increases the angle of incidence from this normal, so we will find that we will get a good amount of polarized light. This angle at which the polarized light is obtained, and this angle is called as the polarizing angle. And the polarizing angle, it is also been said by one scientist who works on it, and it's called as the Bristow's angle. So what is this Bristow's angle is? It is the angle of incidence at which so one can able to get the maximum is the polarized light. So this angle is called as the polarizing angle, and also called as the Bristow's angle. So what is this Bristow angle says? So he says that the law says that the refractive index of the media is equal to the tangent of the polarizing angle. So this is what the Bristow law says. The refractive index of the media is equal to the tangent of the polarization, and this can be geometrically, it can be proved if you can imagine this. So now we have a figure here. So this is the incident a ray. So that is, so here this point of intersect, if we can take it as O, this point of intersect take it as O, then OP is the incident light and OR is the reflected light and OS is the refracted light. So I hope I will continue this because of time shortage. I hope I will continue this next time. Till that, so have a good day. So goodbye. Please keep studying. The examinations are ahead. Okay. Thank you very much.